this moment, I will be discussing principle of mathematical induction, or using principle of mathematical induction, or PMI, to prove this given statement or problem. So here we have 1 squared plus 3 squared plus 5 squared plus so on and so forth, plus the square of 2n minus 1 is equal to 4n cubed minus n all over 3. So first we will prove that this formula is true given that n is equal to 1. So our n is, or this is the first term, right? So our first term is 1 squared. So 1 squared is equal to 1. And now using the formula with n as 1, so here we have 4 times 1 cubed minus 1 all over 3 is equal to 4 times 1 minus 1 all over 3. So 4 times 1 is 4 minus 1, 3, then over 3. So 3 over 3 is 1. So the assertion holds for n is equal to 1. Now for the second part, we will have n is equal to k, and so therefore the sum of n is also equal to sum of k. So because in this part we will be testing out if our formula would still hold if n is equal to k plus 1. So here, substituting n with k. So the sum of our n, this is the sum of our n, right? So here we have the sum of our k is equal to 4k cubed minus k all over 3. And so, if n is equal to k plus 1, so our sum of k plus 1 is equal to 4 times the cube of k plus 1 minus k plus 1 all over 3. So the cube of k plus 1 is k cubed plus 3k squared plus 3k plus 1. So we will multiply that by 4. Then minus 3 plus 1 all over 3. And here we have 4 times k cubed is 4k cubed. 4 times 3 squared, 12k squared. So 4 times 3k, 12k, minus k, 11k. 4 times 1 is 4, minus 1 is 3. Then all over 3. So for in this part, we need to show or prove that using this one and the other formula, which I will be showing to you. Okay, so we'll prove that this one, the formula that we came up with by just directly substituting k plus 1 to our sum of n, it needs to be equal to using this other method, which is the sum of k plus 1 is equal to s, or the sum of k plus 1 term. So this k plus 1 term is the term that is next to this. And we need to remember that this will be substituted by k, right? Using, if we have this as our sum. So therefore this n will then be substituted by k plus 1. So that is what k plus 1 term means. So the term next to this one. Okay, so by using this method, here we have sum of k is 4k cubed minus k all over 3 plus the square of the k plus 1 term, which is 2. The square of 2 times k plus 1 minus 1. And now we have 4k cubed minus k all over 3 plus our 2 times k, 2k, 2 times 1, 2, minus 1, so the square of this one equals 4k cubed minus k over 3 plus the square of 2k plus 2 minus 1 is 1. So the square of 2k plus 1. And here we have the square of this is 4k squared plus 4k plus 1. So in here, we will add these two. So their common denominator is 3. So here we have 4k cubed minus k plus 3 times 4k squared plus 4k plus 1 all over 3. Now, here we have 4k cubed minus k, 3 times 4k squared, 12k squared, 3 times 4k, 12k, 3 times 1 is 3, all over 3. And now we will be combining like terms. So 4k cubed plus 12k squared, and then we have 12k and negative k, so we now have positive 11k or plus 11k plus 3 all over 3. So as you can see, this formula that we came up with by using this method is equal to the formula that we came up with by just substituting k plus 1 directly to the sum of n. So you can see 4k cubed plus 12k squared plus 11k plus 3 all over 3. So the assertion is also true for k plus 1. Therefore, by the principle of mathematical induction, 1 squared plus 3 squared plus 5 squared plus so on and so forth plus the square of 2n minus 1 is equal to 4n cubed minus n over 3 is true for all natural numbers. And that ends our proving by PMI or mathematical induction.